Hello students, as I'm recording this video I've just gotten home and it's 75 degrees outside, so I was in a spring colors sort of mood. So this is Unit 3 Lesson 5B. We did Lesson 5A just to review or introduce complex numbers and imaginary numbers and complex roots, which you remember complex roots come in pairs called conjugates. So we are continuing that with this is just one page. This lesson is just one page. There's a little bit of introductory stuff I want to do, and then we're going to look at these examples on page 14. So you see your objectives here, which some of them we already covered yesterday. But today we want to learn to write our polynomial functions when we're given complex roots in standard form. We talk about complex roots, but there are also irrational roots, which is like square root of 2, things like that. So anytime you see a root like that, they come in pairs as well. So also by way of review, I want to remind you that when you see a pair of binomials such as x plus 3 times x minus 3. This is what we call, these are the binomials that make up a difference of 2 squares. If you see the same 2 terms in each parentheses and there's a plus in one and a minus in the other, your middle term is always going to cancel out. So you multiply the x times the x, and then you have a negative 3x and a positive 3x, and those are going to cancel every time. And then you have a minus and then 3 times 3. So what you end up with is x squared minus 9. And this is what we call difference of 2 squares. So anytime we see something like this, we know that we can factor it like this up here, but we also want to recognize that if we see the same 2 terms with a plus in one parentheses and a minus in the other one, that is always going to be the square of this term minus the square of this term. Just another example with a different type of number. If we see something like this, square root 2 or root 2 is an irrational number. We want to leave it like this. We don't ever want to put that in the calculator and round it. So, but if we did see this, it would be x squared, and then your middle term would cancel out. So we don't even need to deal with the middle term. It would be x squared minus, and then root 2 times root 2. We talked about that a little bit in yesterday's video, but root 2 times root 2 is just 2. So it would be x squared minus 2. So let's look at a couple other examples that have complex numbers, or they might have, this is like a factor for a polynomial function. And then down here we have another, we've got factors for a polynomial function as well. Just want to practice a little bit with these. So if we were to multiply this red pair of binomials here, we could use the FOIL method. We can do 3 times 3, that's 9. And then 3 times 2i, that would be plus 6i. And then we would have 2i times 3, that would be minus 6i. And then we have negative 2i times positive 2i, so that would be, I'm going to just say plus negative 4i squared. These 2 terms always cancel out. Again, it doesn't matter what the 2 terms are in the binomials. If you see the same 2 terms in both binomials and a minus in one and a plus in the other one, you don't need to mess with the middle terms at all. So you can just do the first terms and the last terms. So it would be 9 minus 4i squared. But if you remember from yesterday's video, I squared, we need to change that every time we see it. We can't leave it like that. So this is going to be 9 minus 4 times negative 1. Well, 9 minus negative 4 is the same as 9 plus 4, so that would be 13. All right, let's look at this one. Again, I'm not dealing with the middle terms. I'm going to do the first terms, x squared minus, and then 4i squared. So that would be x squared plus 4, because it's minus 4 times negative 1. Which is minus negative 4. So this would be the simplified version or the standard form of that one. All right, let's look at one more. So we would do the first 2 terms, or the first terms, square that, and then it would be minus, this is going to be 2 squared, which is 4, times root 3 squared, which is 3. So it would be x squared minus 12. This one didn't have an I in it, so we didn't have to deal with that. Okay, so this is also kind of a review. We haven't gotten to page 14 yet, so I just want you to watch. If you want to write this somewhere on your blank paper from yesterday, you can. If I were to tell you that there's a polynomial function that has roots at -3, 1, and 4, and I would say write that function, write that equation, what you would do with the 1 and the 4 is you would put in parentheses x minus 1 and x minus 4. It's always x minus whatever the root is. So if it's x minus the root, then x minus -3 would actually be the factor here. But of course, we just always write that x plus 3. This is important to remember when we start looking at conjugate, complex conjugate roots. So just keep that in mind, that it's always x minus whatever the root is or whatever the x-intercept is. But we, of course, we changed this to plus positive. So then looking at this example, roots at √3 and -√3, we would write y equals x minus √3 and x minus -√3, which would be plus √3. And then, of course, we could, excuse me, we could multiply this out. So if you were told to write it in standard form, it would be x squared, excuse me, x squared minus √3 times √3 is 3. Okay, so this one's a little bit different. At first glance, you might think, oh, I'm supposed to just multiply 3 plus 2i times 3 minus 2i. But this is a polynomial function. If I said you've got a polynomial function and you've got roots, this is one of your roots and this is the other one. This is a conjugate pair. So if you have this root, you've got to have this one. Then you would write this, y equals, and then you would write x minus 3 plus 2i. And that would be, we'll put this in parentheses because it's a little bit easier to see. And then you would have x minus 3 minus 2i. It's always minus the roots. So then we would just need to rewrite this as x minus 3 minus 2i. And then x minus 3, and remember that distributes. Remember, if you're subtracting something that's inside parentheses, I should put another one right there, then you want to distribute that negative in, so that would be plus 2i. Now, I'm not going to carry this one any further than this, but what I want you to understand is this is a trinomial and this is a trinomial, and you would have to, and you have to multiply all this out. You have to get it to standard form to get rid of the I part, because you can't graph it with the I in there. But you would have to take this x, distribute it in the parentheses, and then, oops, should have gone to the x first, and then the -3, and then this last term. So you're going to end up with 9 terms down here that you will combine like terms. And we're going to do one like this. I just didn't want to do this one right now. I want to practice some that are a little bit simpler than this first. Okay, so here we are on page 14. This is at the top, and this is just the title of our lesson. But I want you to note that it says any root with a square root or an I is going to have a conjugate root. It's going to have a pair that goes with it. I should say a partner that goes with it. So if I said there's this polynomial function that has a root at square root of 9, well, you'd also have to do the opposite of square root of 9, which would be plus 3 or minus 3. But if it's put in that term where it's a square root, a square root number, then you're going to have 2 of them. If I said there's this polynomial function and it has a root at, or a 0, whatever you want to call it, a root at 3i, it also has one at -3i. So anytime you see an irrational or a radical root or something with an I in it, it's going to have 2 of those that kind of match. They're conjugate partners, conjugate pairs. Okay, so let's do a little practice on irrational and Imagineering complex numbers. So if you see something like this, like if you see square root of 7, its conjugate root or its conjugate partner would be the opposite of that, which is negative root 7. The conjugate root for negative root 3 is just positive root 3. Conjugate root for 3i, negative 3i. Conjugate root for negative 2i is 2i. This one is written in standard form for complex numbers. So this one's going to be 1 minus 5i. This one is written backwards. So this one, what we're going to do is we're only going to change the I term. So the conjugate root for this one would be negative 3i minus 7. So the negative 7 or the minus 7 stays the same. It's the I term that changes to its opposite. Okay, here we go. Number 1 on page 14, the first example says, write a cubic polynomial. So I know that has to add up to 3. In standard form, it's got to be in standard form. We have roots at 2 and at 3i. Leading coefficient is the a value. So if you want to write a value, same thing. Down there, leading coefficient of 1/2. So first of all, I know it's a cubic polynomial. So I know it's got to add up to 3. Let's put our a here. And then I know I'm going to have an x minus 2. I also know I'm going to have an x minus 3i. I need to recognize that if I have a 3i, I also have a negative 3i. And x minus negative 3i is x plus 3i. Oops. Okay. Oh, I'm sorry. They gave us the a. I didn't put that in there. That should be a 1/2 right there. Okay. So now we have everything we need to write this in standard form. The first thing that I would do is I would always do my conjugate pairs first. So I would multiply those first and then leave this out. I did notice on the quiz that some of you were a little bit confused when you had 3 binomials that had to be multiplied, and then sometimes you would forget to multiply the a-n at the end. Keep everything straight. If you do really neat work and you don't leave anything out, then you're less likely to make an error. So let's do these complex the conjugate pairs first. This is going to be x squared, and it's going to be minus, let's write this over here, minus 9i squared, but 9i squared is negative 9, so the opposite of 9 times negative 1 is going to be plus 9. So this is going to be x squared plus 9. And if you might have already realized that you square this, and then whatever this times this is, you're going to write a plus, and it's going to be 3 times 3. Okay, so now I've got one thing multiplied. I saved the 1/2 till last. And so then I'm going to multiply these two binomials right here. Y equals 1/2, and I'm going to multiply that in last. So this is going to be x cubed plus 9x minus 2x squared minus 18. Okay, so I can rewrite this in standard form. Okay, and then multiply that 1/2 in there, which means just divide everything by 2. So let's see, 1/2 x cubed. Negative 2 divided by 2 is negative 1, so minus x squared plus 9/2 x, and then negative 18 divided by 2 is negative 9. So this would be that cubic polynomial, and you see the leading coefficient is still 1/2. It's cubic. The highest degree is 3. Okay, so our next one says write a quartic polynomial, which means it's going to add up to 4. In standard form, zeros are at negative 3, root 2, and 0. It's quartic. If it has a root 2, it also has a negative root 2. Leading coefficient, which is the a value of 1, so I don't need to worry about that. Okay, so let's see, let's get this started. Y equals, I'm going to have an x minus negative 3, which is x plus 3. I'm going to have, you can put x plus 0 or x minus 0 if you want. You don't have to. You could put the x up here. In fact, I think that's what I'm going to do. Anytime you have a 0, root. You can just put the x here. Just don't forget to multiply it in. And then I have x plus root 2 and x minus root 2. Okay, so I'm going to do this part first. I'm just going to rewrite everything else. This is going to be x squared, minus 2. Minus root 2 times root 2 is 2. Okay, so now I'll go ahead and distribute this x in here so I don't forget about it. So this is x squared plus 3x. Now I need to multiply these two binomials together. And then I'm done. X squared times x squared is x to the 4th. X squared times negative 2 is minus 2x squared. Might have some like terms, I'm not sure yet. 3x times x squared is plus 3x cubed. And then 3x times negative 2, negative 6x. I just need to rewrite it in standard form. And that's going to be important when we do our division next week. So just get used to writing these in standard form with the descending exponents. Okay, there it is. Okay, our last problem is the toughest one. We're going to have a lot more to multiply through, but we'll take it slowly and take one step at a time. And we'll be less likely to make errors. Okay, polynomial cubic means it adds up to 3. It has a root at negative 1. And here, this is a whole root right here, 1 minus 3i. So since it has an imaginary number in it, it also has a conjugate, which is 1 plus 3i. Leading coefficient, negative 2, that's the a value. So let's start writing this. We have an x plus 1, and then we have an x minus this whole thing. Okay, let's talk about what that looks like. X minus 1 minus 3i. Remember, when you have a minus and then you have parentheses like this, everything changes to its opposite. So this is like x minus 1 plus 3i. So that's what goes in this one, x minus 1 plus 3i. Okay, and then we're going to have x minus this whole thing. So these both just change to their opposites. All right, so I have my factors and I have my leading coefficient. Now I need to multiply everything together. I'm going to go ahead and multiply the negative 2 into these parentheses, but then I'm just going to hang on to that until the end. So I'm just going to leave that like that, and I'm going to start multiplying this stuff right here. This is a trinomial times a trinomial. So I'm going to use some colors to make it a little bit easier, hopefully. So I'm going to underline this first x in black, and then I'm going to underline all of these just to show I need to multiply this times all of these. And I'll do that in black. X times x, x squared. X times negative 1 minus x. And then x times negative 3i, we're going to write negative or minus 3ix. That's how we're going to write that. All right, then let's do green. So I'm going to do negative 1 times all of these. Negative 1 times x minus x. Negative 1 times negative 1 plus 1. Negative 1 times negative 3i, that's going to be plus 3ix. All right, let's do blue. Oops. Okay, I'm going to multiply the 3i times everything in here. 3i times x is I did something wrong. Let's see. That's negative 3ix. I'm going to pause. Okay, I found it. So negative 1 times negative 3i was just positive 3i. So this shouldn't have an x on it. Okay, let's finish this thing. Okay, 3i times x is plus 3ix. 3i times negative 1 minus 3i. 3i times negative 3i. Let's talk about what that is. That is negative 9i squared. Negative 9 times I squared is negative 9 times negative 1. So that is plus 9. Okay, let's cancel some stuff out here. Let me get a black, a little bit thicker marker. Okay, so I see a negative 3ix and a positive 1. Those cancel. Mark it out. I'm going to do a really good job of marking these out so I don't get them confused. Okay, positive 3i and negative 3i. And just so you know, the imaginary numbers should always cancel out somehow. Okay, I think that's it. Now I need to combine my like terms. Get my pink back. Okay. Still, just write y equals and then write your negative 2x minus 2 right here. Okay, let's combine terms. Let's see, x squared. Negative x plus negative x is negative 2x. And 1 plus 9. Okay, we're almost there. Now we got to multiply the binomial times the trinomial. So I'm going to multiply the negative 2x in, and then the negative 2 in. Negative 2x times x squared. Negative 2x times negative 2x plus 4x squared. Negative 2x times 10 is minus 20x. Okay, got that taken care of. Negative 2 times x squared. Negative 2 times negative 2x. And negative 2 times 10. Okay, now we just need to combine like terms. There's an x squared term and there's an x squared term. There's an x term right there and an x term right there. So I just need to combine those. Let's see, that's going to be not minus 16x. And then minus 20, I believe. Let me just check my key and make sure I've got the same thing. Yep, I do. Okay, so this is standard form. And I know that was a lot of fun. So we'll work on these some more tomorrow. We'll do pages 5A and 5B classwork tomorrow.